Okay, so our last way to solve a quadratic is to actually use a formula. Very famous. Many of you have probably already used it, and we're going to take a look at it and use it ourselves in a bunch of different situations. So let's consider the following quadratic equation. Again, right now, knowing what we know, it doesn't factor very well, right? So we have 4 times 9 is 36. So if we multiply two things and get 36, we need them to add up to -5, and no numbers exist that do that. So this doesn't factor very well. It definitely doesn't involve the square root property because that -5x is in the way. And then if we tried using the completing the square process, that process works all the time for all of them, but the first thing I would have to do is divide everybody by 4, right? And so that creates that helps us with the first problem of having a coefficient out front that is 1, but now I've got to take half of that and square that and move this to the other side. Lots and lots of fractions. Very doable. I'm pretty sure you guys can do it. You guys have really advanced the ball with your fraction world, but you know, there's got to be an easier way. And we've done in probably 2 days or 3 days, how long it's taking you to do this. We've kind of reached that point too where, hey, we want an easier way. And the ancient cultures were the same way. The people who did this, they had this way that worked. It worked all the time, but man, it got a little hairy, trying to solve it with all these fractions. Is there an easier way? So I'm not sure who the mathematician was who thought about this, but they said, well, why don't we just take any quadratic, right? So we're not going to do a specific one. We're going to let A be any number, let B be any number, and C be any number, and let's complete the square on this process. And again, it's going to look really messy. You guys don't ever have to do this again, but I just want to kind of show you how the quadratic formula was built. All right, so because again, we know that the completing the square process came first. So we're completing the square. The first thing I have to handle is the fact that my lead coefficient is not 1, it's a. So we'll divide everybody by a. So that gives us x squared plus b over ax plus c over a, and then anything divided into 0 is 0. Okay, second move is we now have to take a look at the parts that represent the incomplete square. So I'll subtract c over a from that, and we get x squared plus b over ax equals -c over a. Again, there's my incomplete square. We begin completing it by taking whatever this coefficient is and dividing it by 2. Alright, so for fractions to divide, we actually multiply, so we get b over 2a. Alrighty, and so let's go ahead and kind of keep that important, because that's our flap, if you would. And so I need to know what I need to add to this, so we're going to take b over 2a and we're going to square it. And so we have a product, we have a quotient, everybody gets squared. So there's the area of that little chunk that we need to add to complete the square. So I'll come up here and I'll add it to this side to complete the square, and I will add it to this side to complete the square. All right, and I'm going to just write it in this form because I know what I'm trying to set up later. Okay, so far so good. So we're pushing those fractions around. This is as bad as it can possibly get. And so what we know on this side, it's a perfect square trinomial. And if you've been paying attention, this value right there plays a huge role in the factorization. So on this side we get x plus b over 2a squared. All right, equals, if we do work on this, we're subtracting 2 fractions. And so what I need is a common denominator, and that common denominator is 4a squared. So this already has it, and this I would have to multiply top and bottom by 4a. So we end up with b squared minus 4ac all over 4a squared. And for those who are probably in the know, who know this formula, you're probably starting to see something already like that's important to it. Okay, so what's our next move? Well, now that we have this part squared, to solve for x, we take a square root. So I'm going to take the square root of this side, and I add, right, a plus minus on that side. So over here, the radical clears out. All right, over here, we can apply the radical to both the upstairs and downstairs. Okay, we cannot break up a radical over a difference, but I can break it up over a product. And so we end up with x equals b, x plus b over 2a equals plus or minus the square root of b squared minus 4ac, and then that simplifies to 2a. Solving for x, I'll now subtract b over 2a from both sides, and we get that x is negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Whether we're adding or subtracting, what's good is my denominators are the same, so I can write this as one entire fraction. So my denominator is 2a, and up in my numerator I have minus b plus or minus the square root of b squared minus 4ac. And that is our value for x. So we're taking an equation, we're trying to find what values of x solve it, and after going through our completing the square process and all its craziness, there's basically our formula. What's nice about it, again, the a is the lead coefficient, the b is that middle coefficient, and the c is the last coefficient. So as we've seen, right, the way that we use a formula is I come back over here, right, and I figure out what a is, right? Well, in this case it's 4. I figure out what b is, it's negative 5, and I figure out what c is, it's 9. And so in order to solve this equation with this formula, is all I got to do is plug things in. So let me rewrite the formula over here so we can get a good look at where I'm plugging things in. So x equals, well, it's going to be negative whatever b is, right? So that's negative 5 plus or minus negative 5 squared minus 4 times a times c. And this is all over 2 times 4, which is a. So we just plug it in. And now all that we have left to do is a bunch of simplification. So we get x equals, well, if we negate a negative, that's 5. Doing the math inside here, negative 5 squared is 25. And I believe here we're going to get 36 times 6. 6 times 6 is 6. Carry the 1. 18, 196. So minus 196 all over 8. Alright, and we can already begin to see why we were having a tough time factoring this, because when we subtract that, let me do it this way right now. So when we subtract that, we get 171. So we get a x equals 5 plus or minus the square root of negative 171 over 8. Alright, and that is crazy. We have a square root of a negative, so that incorporates an I. I believe 171 is prime, and so there would be our solution to that equation by using the quadratic formula. And again, like any formula, what the beauty about it is all I got to do is to figure out who is who, plug them in, and then we're back to evaluating and going to work on that. So there's how we solve that one. And there is your quadratic formula. Word of warning, you guys, as we work through things, I believe you guys are going to love the quadratic formula. As all formulas, it's very nice. But you really should, especially if you guys are going to be moving on to higher mathematics like Math 150, College Algebra, some trigonometry, 182. If you're going to be going to a calculus class, whether it's 210, 212, 220, whatever it is, the process of the completing the square is very important. So please make sure you still remember how to complete the square, although your preferred method might be the quadratic formula. Alright, so let's go practice this in some other videos.